and we will now pass on to Marcia for her talk on migrating existing applications to serverless.
Thank you.
Hello, I hope you can all hear me. I will share my screen and let's get started. I, in general, been doing this presentation in slots of 1 hour. So I hope you're seeing my screen. It's working. So I have made it shorter, way shorter, but I'm happy to answer any questions then offline. So we are going to talk today about how to migrate an existing applications to serverless. I will talk a little bit about some of the examples are more about monolith and also microservices. So it's a mix of both. First, I want to introduce myself. My name is Marcia. I'm a developer advocate for AWS. I've been in the company for 8 months. And before that, I've been doing serverless as a developer for, I don't know, since 2016. So since quite early from the serverless wave. I'm the host of a YouTube channel. As they mentioned at the beginning, I have over 250 videos on serverless where you can learn all kinds of things. So if you are interested in getting your hands on this, go and check it. So let's get started. So the presentation will be split in basically 2 parts. First, a not that successful story on migration, and then a successful story on migration. The non-successful story is my personal story. And the other one is one of the AWS customers that did a really great job. But first, just that everybody gets with the same picture of what is serverless, I want to go through what it means to have a serverless architecture, to have a serverless components, or to have serverless whatever you like to call it. I call it a methodology. And the idea is to maximize the value without doing basically rewriting the wheel, making the wheel again. So these are 2 comments from 2 different serverless influencers, Jeremy Daly and Jared Short, and I think they explain very well what serverless is. Basically, if the platform has it, use it, get it from the market, try to think about how you can reutilize as much as possible and focus on what really provides the core value for your stakeholders. So something is serverless when it agrees with these 4 kind of characteristics. It scales automatically. Basically, you don't need to be on call or anything. If it goes viral at Korea in 3 in the morning, you can be sleeping and you don't care. You pay for how much you use. Well, the scaling automatically, there are always soft limits and edge cases, but it's not as you need to be paying attention a lot to them. Well, you need to know them, but you don't need to be like after you know them, then everything should be fine. You pay for how much you use. It's like electricity. You have a bill at the end of the month on how much you have been using. You don't need to manage any infrastructure whatsoever. You don't need to care about what version of the operating system Lambda is running or S3 is running or anything like that. You are super abstracted from your infrastructure. And then it comes with high availability built in. And that's something, for example, if you're using virtual machines in the cloud, you might need to deploy it with one availability zone and have that managed. But when you're working with serverless, you're deploying inside the region and you will get the benefit of having your systems available into multiple availability zones. So basically, building serverless applications is like putting Legos together. You have all these components, computing components, you have, I don't know, storage component, networking components, APIs, queues, messaging, and you need to build them together into something that looks like this, that it's maybe a little bit, I like this example because it's a very busy picture and I don't think it's a good example to display an architecture like this, but it's a real architecture of a social media that the Burning Monk, one of the serverless heroes, have created in the past. And I think it's a good representation. If you put everything in the same picture, it just looks like little Lego blocks connected to each other that do small little things and make the whole system work. So let's start with the first story. That is my story, my first serverless project ever. We were it was 2016, early 2016. And I was working in this company where we're making like a Netflix for cartoons. It was a very successful project. It has been out for 5 years already. And we have around 6 billion views. So it was very, very successful. You know, kids like to replay and replay the videos a million times. And the thing with this service is that it was free. We were monetizing by ads. So when you're doing a service that is streaming video on the internet and getting money from ads, then you need to be very conscious on your spending and on your architecture. This application was created by a small group of developers, including me, and we were all very cloud naive. We didn't know much about cloud economics. We just built Java applications that were microservices that ended being small monoliths because we were too lazy or too busy. I don't know how we like to call it. And because it was also hard to deploy new microservices. And it ended up being quite expensive to run in the cloud. So we got a message from stakeholders that says that our project will get canceled if we don't do anything about it. The first thing we did was try to optimize the code. As we knew, as developers, we tried to add caches and add all kind of things, but nothing helped. So it was summer and I was doing some pet projects. Serverless was cool. It was starting out and I was playing with it. And at the same time, we were rethinking the architecture because we realized that we needed to do an architecture change in our application. And we realized that we needed to do a massive architecture change. So I told my boss, and my boss, maybe he was too good, I don't know. I told my boss, hey, let's go with the serverless road. And he said, sure, why not? Nobody knew how to deploy more than 4 lambdas. That was all my experience in serverless. So this was a bumpy road. We were 3 developers taking the lead on this, and we decided to go through a not really good path. That was the big rewrite. And I think this is not a good migration strategy for anybody. We have a project, it was not a big project. I think we calculated and we were quite good in the planning. We calculated it will take 6 months to rewrite all, and it took around 8 months to rewrite it all. And we decided to go to production one day in the future. It was bad, very bad. Very, very bad. First, because, well, you know, the requirements, the application keep on growing as time passed because new features were added and we needed to add the new features and we needed them to migrate them, and that was a bad idea already. Then everybody was like super pending on our migration. We had a lot of pressure. We were working on all kind of parts of the system, and we were taking decisions at the beginning of the project, like our CI/CD pipelines, monitoring, and all kind of things that then were basically we were testing them for the first time with real production information on 7-8 months down the path. So it was a very, very painful experience. We managed to migrate it. It took many, many weeks. I don't know how long it took. It seems like years. It was not years. It was many weeks of lots of work, lots of crunching, and lots of learning. And also this, I think, applies to any new technology, because by that time there was not much documentation on serverless, not much experience on how to migrate, not much experience on how to manage production services on serverless. So it was very, very painful. So I don't recommend this strategy whatsoever. The strategy that I would recommend is the one from our second story, that is the story of Comic Relief. Comic Relief is a British company that, well, they're an NGO. They're not a company. They take over the television. Maybe the guys watching this from UK know this company. They take over the television for one day. They invite actors, musicians, comedians, and they get money, they get donations, and then they donate them to some good cause. So it's one day basically at the year where they are getting lots of money and lots of donations from many people. And before they did the migration to serverless, they were able to accept donations once a year because they need to set up such a very complex system, and they could not afford it doing it after this time. So they have one big challenge on this service, that it was that they have 350 donations per second. Maybe you think it's not that big number, but it is, because donations is not something that you can do duplicates. you cannot retry, you cannot lose. They're very critical information that needs to be handled very careful. If you lost one donation, people might not come back and donate. If you do 2 times a donation, that's not a good idea. So each donation is very, 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 very important. And this is a very critical part of the whole system. And if they fail here, they also will lose the trust of the audience that are watching, and the audience might not want to donate. So by 2016, they started their kind of thinking of migrating. They started more or less at the same time that we did. And this was the architecture they have. They have one big monolith for Drupal for their content, static content and things like that. Then they have one page for giving pages, and we are not focusing in there. And then they have another monolith or microservice that was too big that is for the donate. And this is the part that is the critical part of the system, the one that they wanted to migrate out and to make more flexible and easier to handle and more resilient. So here they started asking the question, where we need to start migrating from. Sometimes we think about the strategy 1, that is to start migrating from the least critical part of our system, start migrating something that is not relevant, that nobody cares, so we can make mistakes and try things. But then when is the point that we need to move to this migrating the critical part of our system, the one that will get us the most return on our invested time? Sometimes we want to start with the second strategy, and that's not good. We don't want to do that. We want to do a mixture of trying with the first strategy, migrate as many small things as we can, test our decisions, our CI, our monitoring, and our infrastructure as code, that the team learns, that they feel comfortable, and then we move to the most critical part. So that's what this team in Comic Relief did. They started by migrating something super small thing that it was an image gallery with some pictures that they were not really a critical component. Nobody really watched them that much. And they migrated to serverless and to newer technologies like React and took it out from the Drupal monolith. And they started to feel comfortable that this is something that is the right path. In 2018, they migrated some other small services that maybe they were a little bit more critical, like the contact us form, but still quite simple. And they also started creating a whole framework to reutilize components around their different services. In 2019 is where they did the big bang of migrations, and when they migrate the Donate platform. And here is when the whole thing changed. Now they can accept donations all year round, and their whole architecture now from the perspective of the critical part is serverless and using modern technologies. So if you want to take a look at the architecture, it's available in this URL. You can take a picture and take a look at it later. But basically the architecture is extremely resilient. So all the different donations are coming into the service, into the system, and they have multiple layers of failover. If there's any problem, somebody's going to take care of those donations. So nothing is get lost, nothing comes duplicate, and there is no problem with it. And this is one of the most interesting graphs, I think, that they had is the cost. So before starting their process of migration in 2015, they have $84,000 of cost per year in all their computing and storage and whatever IT things that they have with their Drupal and all the stuff. In 2019, after the migration was done, it was $5,400 a year, and from which only 92 was about this Donate service. The rest was basically their Drupal monolith that they have for their static content and for other things. And they have everything as infrastructure as code. They can replicate it as many times, they can test it, they can grow it, they can change it. And the most important thing is that they can accept donations all the time. So if you want to donate, you can do that. So basically their strategy was a simple strategy, a strangle pattern strategy. And this applies to monolith as well as to services that we want to get out. So it's taking pieces of code and migrating in a graceful way. And also if you have a monolith, you need to manage the API and the database. So let's look at 5 simple steps to migrate to serverless. And usually this part takes me like half an hour, and I'll try to do it in like 10 minutes. So the first thing that you need to do is to think your foundational work. And this is something that is very important. And your foundational work is basically deciding on what is the microservices that you want to have, how your system should communicate to each other. You can decide on the size of the microservices that you're going to have. I like to work with this 2-week rewrite size. So you make microservices that are big as that you can rewrite them in 2 weeks, because you want to have an architecture that can evolve and can change, and it's kind of easy to throw to the trash and start again if something changed. Then you need to pick your developer tools, your frameworks, your programming languages, your, I don't know, whatever you need. And sometimes when you're working with serverless, you might need to pick different tools for different problems. So for example, and I think this applies to any technology, for serverless, you might want to use, if you're working with Lambda functions, you might want to use serverless framework or AWS SAM. If you're working with more static AWS infrastructure, you might use CloudFormation or CDK. If you're working with the front end and GraphQL, you might want to use Amplify. So depending on which type of microservice, you might want to pick different type of tools. And this applies as well for the infrastructure as code. This is something you need to have from day 0. Before starting anything, all your developers need to be trained on how to use infrastructure as code. In serverless projects, developers are building infrastructure, and that's something very important to have in mind. It's not only your ops teams that will be building infrastructure, but developers will be building functions, messaging queues and event reach and things like that. So they need to know how to write infrastructure as code. One very important thing is that you have a CI/CD pipeline and you decide how things are going to be deployed, what kind of stages and what kind of type of deployment you will have. Are you going to do canaries? Are you going to do safe deployments? Whatever, how your tests are going to run, everything needs to be defined. You want to test this and iterate over it, as when you're doing the steps in your strong loop pattern, you're migrating things and testing your foundational work all the time and improving it. So when you get to migrate your critical part, all this foundational work is extremely oiled. And very important, monitoring and observability. When we started our migration process, that failure story, we didn't thought about monitoring and observability first, because by that time there was no serverless observability tools. Second, we didn't know that monitoring serverless applications is very different than monitoring traditional applications. So that's something you need to master, because debugging serverless applications is very hard. You need to be able to trace your requests through multiple different services and resources and asynchronous calls. So you need to have that in place from day 0. It's way harder to do later on. So after you have done your foundational work, you need to start, if you have a monolith, you might need to migrate it to the cloud if it's not, and then you need to start finding those kind of bounded domains of where you will have your new microservices coming out. And then you will organize your code inside your monolith, and also you will start breaking your data dependencies. So you will need to break the database in the next steps. So you want to start creating these little silos inside your monolith, if that's the case. Then you will start moving your code gracefully to serverless. And in order to move to serverless, there are many different things that you need to go do, but I will try to give you at least the most important tips. These are the express tips to design serverless application. The first one is think about logical microservices. You don't want to get your mind that a Lambda function is a microservices. No, a Lambda function is not a microservice. Your whole application is not a microservice. You need to think about microservices as something that you can rewrite in an X amount of time, something that is small. I like to say 2 weeks. I think it's so Newman that said that, and I really like that since I heard it. Then you want all your Lambdas and all the resources to, if possible, be inside one GitHub repo, for example, inside one SAM template, AWS SAM template, or in one CloudFormation template. And so you can deploy this whole microservice in one go. And you want these microservices to be independently deployed from each other, but maybe the internal components might have dependencies on each other. And this will make your application way easier to handle. You want inside your microservices, your Lambda functions to connect through queues or for something else. I will talk about that in a second, not directly. And you want your database to be private to that logical microservice. So any other Lambda function or computing or whatever cannot access your database. It only can be accessed from within your logical microservice. The second thing you need to have in mind, and things you need to refactor your application to, is to adhere to the concept of event-driven architectures. This is something that is super important to have in place when you are working with serverless. And if you start thinking about event-driven architectures, you're starting to get as many of the benefits of having a serverless architecture. For doing that, you need to decouple your services and your functions. You don't have functions talking to functions. That add coupling and that adds complexity. And that makes all your things very, basically at the end of the day, you might be writing a big monolith. So you want to have queues or PubSub, or even better, I like to put between my logical microservices an event bus. This will make everything more scalable, more independent, more modular. So then you can replace one microservice with another one new and nothing will get affected. And this event bus between your microservices is very important. Is a way that all your basically microservices can talk to each other and communicate. And if we look at traditional applications before the cloud, you think, oh, event buses are kind of a single point of failure, but that's not the case anymore when you're working with serverless technologies in the cloud. There is event bridge, is the same idea of an event bus with all the benefits of a managed service. And that's my third tip. Replace whatever you can with managed services. Don't manage it yourself. Don't do managed queues. Use managed queues. Don't have a system to manage queues. Don't do authentication yourself unless it's something that is really giving value. Try not to do it yourself. Try to replace it with something that is either in the cloud provider that you choose or in some third parties. There's multiple things that you can choose. For example, you want a NoSQL database. Well, you can go with Dynamo if you're inside AWS and you like it, but then it's Mongo Atlas as well. And there is many others that you can choose. So there is plenty of options and you don't need to have the pain of managing a database that is distributed in multiple nodes and how to scale it and how to manage the keys and how to back it up. It's not your problem and your customers don't care unless you're a database provider. But if you're providing something else, why to bother? So then we move our code to serverless and we refactor it. It's not lift and shift. If you lift and shift, you are not earning any benefits. Just staying wherever you are and migrate to containers if you want to lift and shift. If you want to go to serverless, you really need to break the concepts that you know from traditional application and move to distributed systems and to event-driven architecture. The next step is to break the database. If you have a monolith, you might need to break the database. And even if you have a traditional microservice with an SQL database, you might want to rethink your database now. Sometimes SQL is not the most scalable databases. You might want to migrate it to a NoSQL if possible, or even to files. There's multiple ways that you can do interesting things with files nowadays, and in a file system like S3, you can even perform SQL queries if that's the case. So try to think what is the best way to store your critical data. And finally, we want to talk about breaking the APIs. And I think the previous talk is a good example on how you can do migrations of your customers with, I don't know, 25% of your traffic. Try it a little bit, make sure that it works, and then move the rest. And play a little bit with that. If you're in AWS, you can use canary deployments, linear deployments. You can use also the application load balancer. It has weighted targets, so you can say send 10% of the traffic to my new target. So there is multiple things that you can do in order to be able to move to this new API without affecting your clients. That's something very important. You don't want to go and change the client to this new migration. You want to keep it everything seamless for your clients, but then you might want to try it. I will be, if I will go back to 2016 when we were doing this migration, And there were no tools like this by then, but if they will be, I will be so grateful, because we were migrating basically 100% of our traffic from one day, and then realizing that it did not work. And we were pushing back and moving forward. There was nothing that we could decide now, 10% comes here and test it with a small scale, and let's not affect all the customers. So I think this is something super important to take a look when you're going to a migration. And that's it. Steps: do your foundational work, move your monolith to the cloud, find the bounded context for your code, organize your data layer in your monolith, start breaking out the monolith, refactor to serverless with good strategies, use event-driven architectures, replace as much as you can with managed services, break the database, move it to something that is more scalable and more distributed, and that can take care better of the load and the growth of your application. Break the APIs without destroying your clients, and be able to move the traffic in a graceful way to your new API. And then repeat from 5 to 7 until you're done migrating all the services you want to serverless. And that's it. And I think I did it in less than 20 minutes, I hope.
Yeah, just about. No, that's great. Brilliant. Thanks very much. And yeah, a link to Marcia's YouTube channel is also in the comments. If you want to go on there and click and subscribe, feel free to do so. So yeah, really, really interesting. Thanks very much for that. Yeah, great case study on comic relief. The amount of money this saves is unbelievable. So we've got a couple of questions. So one from Ravi Kumar Siravaj. So what rules do I split a monolith to a group of lambdas? So is it by class or modules, key methods, functionality, etc.?
Well, as I said, you're not lifting and shifting. You will need to do a lot of work to migrate that piece of functionality into a Lambda function. So you should start looking at what is the problem that that piece of software that you want to migrate. It can be a class, or it can be a set of classes, or it can be, I don't know, sometimes when you have a monolith, everything is if it's a good organized monolith, you might have packages, for example, in Java, you might have all your application organized in different packages. So then you can say, well, I will start migrating this package. And then you need to start rethinking with these at least 3 principles that I show you. And there's way more if I will have longer time, but thinking about how you can make it event-driven, how you can decouple all these services, and then how you can take advantage of managed services. So for example, if you have a reporting system, you might just drop all the code whatsoever and go through a whole serverless analytic pipeline using, I don't know, AWS components, just put in an example. So there are some things that you will migrate when it's your business logic. You might need to put that code inside a Lambda function because that's very proprietary for you. But when you're looking at a whole application, there is so much code that is really not providing any value, and it's just moving things from one place to another and doing things that can be done with a managed service. So it goes case by case.
Okay, great. And another one from George Pinto. So what are your thoughts about serverless framework and its own CI/CD solution?
I think the important thing is that you do an analysis on what is the best infrastructure as code tool for you and what is the best CI/CD solution for you. I don't have any thoughts because I cannot tell you what is the best tool. Every project is different, and for example, serverless framework has a lot of great things like the plugin support, it's open source, and it's multi-cloud. So if you want to go through the multi-cloud idea, then you might want to go into serverless framework. If you want to take advantage of a third-party provider for the CI/CD, you can go through serverless framework. I think the important thing is to do an analysis and to be confident that that's the best solution for your particular use case.
And final question from Smith Cloudier, is functional domain modeling and FP a better match for serverless?
FP? Functional programming, maybe?
Functional programming, I assume. Yeah.
So that's something internal to the Lambda functions. I always try to go to functional programming when doing code in general because it's way cleaner and you have less state and side effects. But serverless is not only about Lambdas. Lambdas are just a bit of a serverless architecture. When you start going through making your own serverless architectures, you will notice that you can do a lot of things without putting any code at all. So if you can do functional programming, I will totally recommend it for life, for everything that you can do, just because it's so clean and nice and easy to read. So I don't know, it's good for everything.
Sure. Okay, great. Well, thanks a lot there, Marcia. There's a couple of other questions, one from Andy Hamilton and a couple of others
Yes,
on
I
there.
can
So
answer a little
yeah,
bit
if you
from
can
my
answer
team.
those, that'd be great. And yeah, next up is